Hi, we're going to do problem 20 off of page 381, which is in section 7.4, estimating a population meaning that sigma is not known. So this is the Atkins weight loss program. In a test of the Atkins weight loss program, 40 individuals participated in a randomized trial with overweight adults. After 12 months, the mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8 pounds. So what's the best point estimate for the mean weight loss of adults who follow the Atkins program? Well, for part A, the best point estimate would just be x bar, which was, what was it, 2.1? So the 2.1 would be our best estimate of the true average weight loss. Part B, we want to come up with a 99% confidence interval for the mean weight loss. So because we have to know that x bar is normal. So either we have to know the population is normal, or we have to know that our sample size is large so we can use the central limit theorem. So here we have a sample size of 40. These are 40 adults. And typically people use 30 as that cutoff. So if it's bigger than 30, people usually would say, in this type of situation, the central limit theorem would kick in, and the sampling distribution of x bar would be normal. So we're allowed to use this particular type of confidence interval, x bar plus or minus a t critical value, because sigma is not known, times s over the square root of n. So x bar was 2.1 plus or minus, we'll use the table to get the t critical value. S was 4.8, I believe. And n was 40. Okay? So all we have to do now is figure out what that critical value is. So this is the same t-table that's used to get critical values for confidence intervals. And if we look over here, we want to do a 99% confidence interval. I think that's what the book asks. 99, yeah. So that means we want 99% to be in the middle, which means we have 0.005 here and 0.005 here in each tail. So the total in the two tails would be 1% or 0.01. So if we go up, look at the column headings, you see how this corresponds. The area in one of those tails is 0.005. The area in the two tails together is 0.01. So this column here corresponds to 99%. If we look in the middle, say, if we have 0.05 in each total in the two tails, we'd have 0.025 in each one of the tails. This would correspond to a 95% confidence interval. And so you can do the rest if you're interested. The leftmost would be 99, 98, 95, 90, and 80% confidence levels, respectively. So what we have to do now is figure out the appropriate degrees of freedom to use. Since we had a sample of size 40, for this particular procedure, we would use degrees of freedom of one less than the sample size, n minus 1. So we would use 39 degrees freedom. So we pick the appropriate confidence level, and here we have 2.708. So 2.708 is going to be our t critical value. So I would write 2.708 here, and did the calculation before. So we have 2.1 minus 2.78 times 4.8 over the square root of 40. We get 0.0448. And our upper limit is 4.1552. Like so. So we're 99% confident that this interval contains the true average weight loss. So if we look at part C says, does the Atkins program appear to be effective? Well, for a diet to be effective, I think people would typically say, if you can show that it actually has a true average weight loss, it would be effective. So you draw a little picture like this. If this is 0, 0 means you don't gain or lose any weight. Our interval is from here to here. Since our interval is entirely above 0, yeah, we would say this diet seems to be effective. So that is problem 20 on page 381. Thank you.